Hello, my name is Rajuddin, and today we are going to discuss engineering disasters and the lessons learned from them. So let's move to our introduction. So today we are going to discuss what's engineering at all, what is safety and progress. We'll understand what's the aim and scope of our project, and we will overview in detail the selected case studies. So first of all, let's understand what's engineering at all. Engineering, it's applying of scientific and mathematical principles in order to build, create, and to manage software, systems, machines, which are beneficial for society. But technology, it's like power which we are using in order to create new innovations which make our life more better and easier. But also this power has uh, has has disadvantages which have risks if we don't manage it by using ethical considerations. So let's understand aim and scope of this project. So by in this project we are going to understand the main technical issues, investigate contributing human factors and ethical dimensions, and understand critical lessons and we are going to understand the critical lessons. But understanding by these failures of these crashes, we aim to reinforce the importance of robust design, rigorous testing, and ethical decision making, and continue improvement and in engineering practices. So let's overview three selected cases. So firstly, it's a Chernobyl disaster. Chernobyl disaster, it's a catastrophic nuclear uh, plant explosion, which was in Chernobyl in Soviet Ukraine, and it was the result of reactor and serious operational errors, which handled by inaccurate staff, trained personnel during a safety test. Uh, what's the result of this? It has led to radioactive contamination. It has led to uh, health long-term health effects around this region and about the people and to people, and has led to global re-evaluation of global security test of nuclear plants of all. Secondly, it's Titan submarine implosion. Titan submarine implosion. It has recently been it has recently happened. It was implosion. It was first expedition of Open Gates, which was aimed to discover the Titanic, all its artifacts, what's its current condition, and so on. So, Titanic, not Titanic, submarine was created by new technology using and uh, carbon fiber, and it cannot handle extreme environments in the deep, and also lack of third-party certifications of this submarine, which has uh, which has all the security protocols, and so the reason why all the people which were inside of submarine uh, are dead because of not following all security rules and safety protocols. And the third one was Boeing 737 MAX crashes. There were two crashes of this kind of plane. What was the reason? It was the new software system MCAS, maneuvering characteristics augmentation system, and which was designed to compensate for aerodynamic changes in the MAX, so in this plane. Uh, as in the first case, a poorly trained staff and not following all security protocols during the crashing, it has led to death of more than 350 people at all. So let's understand our selected cases deeply. So first, let's move to Chernobyl disaster.
Okay, good day, Professor. And today I'll talk about the Chernobyl disaster in 1986, and I'll mainly be talking about the event and technical breakdown of the disaster. I ask you to be okay with the camera position. My camera is right here uh, in the line of the keyboard, and that's why I'll be looking at the slide, something a little above the camera. Okay, let's get to it. Okay, let's talk about the background of the disaster first. The Soviets were big on the nuclear power, using a reactor thousand, sorry, reactor RBMK 1000, which was designed to generate an electricity and the weapon grade plutonium. But it was a problem. The problem was when it's cooling, the reactor got more powerful and not less, which was super dangerous, unlike the Western models that cool down. I mean, slow down. And the let's talk about the plant in the Chernobyl nuclear power program was in Ukraine, and was in Ukraine near the Pripyat, and the disaster happened in the Unit 4. So let's talk about the event itself. The event, actually, it was the safety test to see if the turbine could keep cooling pumps running during the power outage until the backup generators started. This test was carried out before as well, but failed, and this time they planned to make it during the routine shutdown, but it went horribly, leading to a massive explosion. Let's talk about the technical failures and the contributing factors to the disaster. Okay, the first of all, the flawed reactor design. What it means is, uh, as I already mentioned, there was a stream. The water got into water became a stream, which was very bad for the reactor, not cooling down. It was called the positive void coefficient, and that was very bad for the reactor. And also, there were many control rod design. There was a control rod design, which means there were control rods initially intended to stop the reaction, but they had a so-called graphite tips, which actually uh, caused uh, reaction, even greater reaction when inserted. That was a really bad kind of decision, or how to say, I don't know, but still, it was a very bad thing to do. Um, and instability at low power. So actually, it was very bad at low power. I mean, the reactor was very bad at low power. Uh, the at the power at the power level when the test was needed to be carried out. So when the test started, it had a very bad performance, let's say. And operational mismanagement and the protocol violations. What it means is, uh, they uh, they let's test procedures, disabling safety system. They kind of ignored the main safety checkups, let's say, right? And they they disabled safety systems like emergency cooling, and that which was against rules. So controlling road numbers. So there were many roads used, as I explained in the flowed reactor design. So also operators understanding and communication. So operators did not really understand the behavior of the reactor, which was a real mess actually. So and the last part, in the inadequate safety culture. So prioritizing production. What it means. So the Soviets were mainly focused on the hitting targets. Hitting targets is like targets was prioritized over the safety checkout, safety matters, safety criterias, and inadequate training is like the employees, let's say the staff working there was were not well trained, were not actually the professionals of their work, of their job. And information dissemination is like um, so actually this kind of thing happened, but not so big one. I mean, they failed in the beginning. I mean, they tried to test, but they failed, as I said. And then next time, I mean, and then when the when the disaster happened, it was planned in the shutdown routine, right? And in a routine shutdown. So in a routine shutdown, they could take some actions to prevent this because they already failed in the beginning, and in order not to fail again, they had to do something, but they just ignored. And no one cared about the last case. They just wanted to do something like hitting the target again, let's say, and not caring about the previous fail that could result in a bigger fail this time. That's it. Thank you for your attention and giving the speech to my friend, next representative Murshad. Thank you.
Okay, thank you, Azizbek. Now we will talk about the Chernobyl's ethical issues, consequences, and lessons learned. So, the Chernobyl disaster was not just a technological failure, it was a human and ethical catastrophe. Operators knowingly bypassed safety systems pleasured by authorities desperate to complete a delayed test. When the unthinkable happened, Soviet leaders chose secrecy over safety, hiding the scale of the disaster. So they delayed the evacuations, endangering lives and silencing the truth. Institutional betrayal ran deep. Reactor designers ignored known flaws. Operators were undertrained and overwhelmed. What about the regulators? They were powerless. The very systems meant to protect people failed, or worse, looked the other way. The price was staggering. Two men died instantly. Within weeks, 28 more were gone, burned from within by radiation. Thousands more would suffer cancers, deformities, and psychological scars that still endure. A radioactive cloud swept across Europe. Entire towns were erased from the map. Over 350,000 people were uprooted. Their homes were poisoned, their futures stolen. Forests, rivers, entire ecosystems rendered toxic. But out of this disadvantage came hard-won lesson the world could not afford to ignore, that safety must never be optional, the truth must never be hidden, that reactors must be designed to protect life even in the worst-case scenario, and that no nation can handle a nuclear crisis alone. Transparency and international cooperation are now global imperatives. The response since has been urgent and transformative. RBMK reactors were re-engineered, operator training became rigorous, new shutdown systems were built, global safety standards tightened, emergency protocols improved. Chernobyl, once a symbol of failure, is now a testing ground for cutting-edge decommissioning and disaster response. Let Chernobyl be the eternal reminder: when ethics are abandoned and human lives devalued, the consequences are not just tragic, they're catastrophic. And when the warning signs are ignored, the fallout has for generations. So, thank you for your attention. Now I'm giving the speech to my teammate Azimjan.
Hello, I'm Azimjan Abdulhidov, and I'm here to speak about one of the examples of technical ethical failures, which is called Titan submersible implosion. And I will speak more about the venture itself and the technical concerns over it. So let's proceed and get some background information. Ocean Gate. Ocean Gate started in 2009 with a bold idea to make deep sea trips accessible to everyone, like for regular people and researchers as well. Their biggest project was $200,000 ride to the Titanic wreck in a sub called Titan. It sounds like a mixture of science and innovation, backed by private money. But there were serious concerns under the surface. Unlike most deep sea subs made from solid metal, Titan used a carbon fiber hull with titanium ends, a combo many experts warned could weaken over time under extreme pressure. Secondly, OceanGate also skipped official safety certifications. Their CEO said that official certification processes slowed down innovation. Instead, they used a system to monitor stress on the hull during the dives. It was like a more wait and see approach rather than prevention. So, above all, there were many employees of the company who raised red flags about these decisions, and they were let go. The app also lacked basic tools like GPS monitoring and was piloted using a video game controller. On June 18th, 2023, Titan lost contact while diving to the Titanic. 4 days later, debris was found, pointing to a fatal implosion. So, the tragedy underscores the importance of balancing both innovation with rigorous safety. OceanGate's story is not just an example of ambition, uh, but also a warning is that in high risk environments, ignoring standards can have fatal consequences. Thank you so much for your attention.
Hello everyone, my name is Abdul Samad and now I'm going to talk about the Titan submersible implosion, the second part of it. So what I'm going to talk now. So I'm going to talk about what exactly went wrong, the fallout, and what lesson we should learn from it. So let's start. So what exactly went wrong? The title's hull was made from the carbon fiber and the titan. The carbon fiber is very light and very strong material. But experts warned that under certain deep sea pressure, the carbon may develop hidden cracks or slowly deform by a huge pressure from high pressure. Also, the some part of Titan submersible uh, was made from Titan material. Uh, which add extra risks, which add also extra risks. Uh, Carbon fiber and Titan, uh, those materials flex differently under huge pressure. And as far as we know, uh, they never run long term from this disaster. Okay, let's move on. Let's switch to certification and classification of this experimental project. Every other passenger of submersible, uh, how to say, Titan was never classed or certified by well-known marine organizations like DNV or ABS. These organizations enforce uh, rigorous standards for materials, welds, and the geometry of any sea devices. OceanGate argued that certification would hamper innovation, but in fact, certification uh, might cause uh, such risks, like I told previously, carbon fiber. And let's move on. Uh, the fallout. Uh, this experiment cost 5 lives, uh, like a father, a CEO of a company, and other people who wanted to see the deep ocean nature. Um like it also costs for U.S. and Canadian Coast Guards support ships and any other force to track to search them, but it never happened to rescue them. So, what lessons were learned? Uh, New composites must endure repeated full-scale pressure tests and risk awareness of any um, device which is close to such experiments, like investigating deep sea ocean. Uh, Governments and industry bodies should close regulatory gaps for tourists. The uh, five people who were in this Titan were all tourists, not scientists or um experts for such field. So government should regulate such experiments. So that's it. Thank you, and to thank you guys so that you listened my part.
The Boeing 737 MAX is a new version of the 737 airplane. It had bigger engine to save fuel, but these engines made the plane's nose go up too much in the air, which could cause a stall. So Boeing added a system called MCAS to push the nose down. And the problem is that MCAS uses data from only one sensor. If that sensor gave wrong data, MCAS would push the nose down even if it was not needed. And this happened in two crashes. First one in Indonesia in 2018, Lion Air Flight 610, and 189 people died in the crash. And the second one is in Ethiopia in 2019, and 157 people died in the crash. In both cases, the sensor gave wrong data, and the MCAS activated many times, and the pilots couldn't stop it. And the main issue is that MCAS was too strong and could activate again and again. It used only one sensor with no backup, and uh, Boeing didn't tell the pilots about the MCAS. Pilots had no training for it, and the FAA let Boeing check some parts by itself, which led to less control. And why this happened? Boeing wanted to sell the airplane quickly because of competition with Airbus. They also wanted to avoid extra training costs for pilots, and so they didn't share full info about the MCAS. And in result is 346 people died, and all 737 Max Air planes were grounded for 20 months, and Boeing lost a lot of money and trust. New laws are made for airplanes and for safety checking, and because it was fixed, it now uses two sensors and activates it once only. And the pilots now train for MCAS in simulators. The FAA now checks more things directly. Boeing and others are working to build the airplanes for better safety. um, the main lesson from this is that this case shows that the safety, honesty, and good training are very important in uh, made airplanes.
Hello, good evening. I'll be talking about the topic about the aircraft, which is Boeing 737 Max. Let me find the topic really quick. Okay, here's my topic: Boeing 737 Max crashes. So the aircraft itself is the fourth generation of the family of Boeing 737. So Max is counted like the fourth generation, and it is really popular company. So let's go forward really quickly about the background of the accidents. The accidents happened because of the manipulations of the company that they made some changes on the aircraft. They made the engine bigger in order to make the aircraft faster. So they even did worked on the design and put the engine on the higher position of the wings, and they worked on the systems. They used the software to automate the system so that the system itself can control the aircraft when it is impossible for the pilot to do it. So then yeah, failures. What will happen exactly? What happened is that when these changes were made, it wasn't made very accurately. The sensors didn't work correctly, so that's why the sensors didn't count the aerodynamics well. So that's why the nose of the aircraft went down more than the particular degree. It was it should it had to go it had to go under for 2 degree, but it increased the level, so that's why it crashed after takeoff of 16 minutes. We had also the failures in the software system. The sensors, as I said, it couldn't calculate properly, so it happened all because of this. So then we move forward to the crashes when it happened. Impacts and rectification overall project. Okay, how it happened. um, what happened exactly is, as I said, it happened in two countries. They all crashed into the sea, and there was so many victims, and the company had to uh, pay for the families of the victims a lot of money, and for the government to gain the security and to gain the again the trust of the government. So they paid a lot of money. They were in minus. They weren't making any profits. They were in debt. So after all this happened, the company had a lot of really I wouldn't say bankrupt, because it wasn't like such a bankrupt, but they had a kind of drawback. Really seriously, it was really stressful situation for the company. And lessons learned. Let's move to the lessons learned. And the company finally realizes they have to, they don't have to, I mean, they mustn't hurry with the deadlines. They have to hire the good qualified pilots that knows the system well. They can control the aircraft well, who is familiar with its functionalities, and who is well qualified. And they now learn the lesson to test the aircraft every time very well, and not hurrying. And for example, they have to take the 5 tests, they have to take 50 tests, for example. They don't limit on the taking 5 tests, they do it 50 times, for example. So it is the lesson gained from them. And comparative analysis, um, about the last happens in cases. If we compare all the cases, for the all cases, we also have, for the all cases, we almost have the similar situation. All aircraft companies, they hurried the cases, they hurried the deadlines, they refused to take the enough tests before the aircraft takes off. They refused to take the to make the transparency in the company. They had the problem in the company. They didn't work with the company, with all colleagues together. They didn't do it all the time. So the lessons, I mean, the reasons behind these accidents was that they couldn't gain I mean, they didn't follow the guidelines well. They all tried to hurry, and finish the aircraft and make the money. It was their aim for the company. Thank you for all. Thank you for watching my presentation here, and thank you for your attention. Goodbye.